So we now know that you can get these subatomic particles coming out, and we're going to talk about the first atoms and how, well, I guess fusion of protons and things into other things soon. Um, but basically, what we want to think about here is how those first atoms came, started, and I guess also how that then led to stars and galaxies. And we're going to, like I said, explore this in more detail soon. But when we're looking at about 300,000 years, sorry, after the Big Bang, basically up till that point, we had enough energy left in the universe that we had hydrogen, helium, and lithium being able to be formed. So basically, you had enough energy that you could actually smash together protons and form helium. You could form lithium, so that's got 3 protons, and but it didn't go on any longer. Like, it cooled down to the point where you just didn't have the production of any more elements. So when you look at the Big Bang and you look at the predictions, and it should be that there's about 75% hydrogen, about 25% helium, and a little bit of lithium. That's actually what's out there in the universe. So it actually predicts it, and we can actually check that out, and it's good evidence of the theory because it does agree. Okay, so we've got these hanging around, but they're just like the nuclei because it's still too hot up until that point for those nuclei to actually capture an electron. So every time they grab an electron, and remember that it should be attracted to each other because they're negative and positive, every time they do that, basically there's all these like really energetic photons flying around that strip that nuclei of that electron. So at about 380,000 years after the beginning of everything, after the Big Bang, it was cool enough. So those photons they'd cooled down, and they were now kind of in the infrared range, and they're just not able to do that anymore. And at that point, the electrons can actually stick onto those nuclei, and we actually have proper atoms. And then we have these infrared photons around, and that's basically the source of the cosmic microwave background radiation that we were talking about before. So this is where that came from. Okay, so those atoms, they weren't spread out completely evenly, and that's reflected in that CMB radiation map that I showed you before. So there's some areas that are denser than others. And basically what happens then is, over time, you get these clusters forming in these clumps, and the clumps coalesce. So gravity pulls them together, and then we get the generation of stars and galaxies. So we'll talk about how that happens soon. Basically, though, as they come together, as the matter crashes together, you get energy being released through nuclear reactions, which we'll talk about soon, and our first generation of stars was born. So these stars aren't around anymore. They were really hot, they were really massive, and they had really, really short lives, but they're really important. They all collapsed as supernovae, which I've got some pictures of them in the corner here, and they're just basically when you get a huge star collapsing, it throws off its envelope of its outer layers in this like magnificent display. So you've got the Crab Nebula below, and you've got the Cat's Eye Nebula there, and you can see those today. So basically, it's in these stars and in those reactions that you get huge, like the bigger elements forming. So things like iron and magnesium and all the things that are like, the iron in your bloodstream is from a supernova, which is really cool. And we know that our sun and our solar system is a second-hand sun. It's not from that first lot of suns. It's the second generation or third generation. And we know that because we actually have those elements here already. Our sun isn't big enough to produce those elements. It's just basically burning hydrogen into helium. But we are lucky that we have a lot of material left around that's actually from the death of a really massive star early on in the universe, which is really cool.